Let us solve one more numerical problem from Pulley Systems. I have done similar problems before also. You can go through my videos. Now, this time, this is a wedge, triangular shaped wedge. This length is, this length from here to here is 4 units of length. From here to here is 3 units of length. And from here to here is 5 units of length. And since this is the longest side and 4 and 3 are the two adjacent sides, and since the square of 3 plus square of 4 is equal to square of 5, that is 9 plus 16 is same thing as 25, that is square of 5. So the conclusion is this triangular shaped wedge makes 90 degree here. This angle is 90 degree. So therefore this is the hypotenuse. And in fact this numerical problem is from the textbook by Professor HCVerma from IIT Kanpur. Now it is given both the surface, this surface as well as this surface, they are smooth, and the pulley and the string passing over the pulley are light, means their masses are not to be considered. Now, and it's also given this mass, let me take it as M1, this let me take it as M2. And as I have told you before, whether this M1 will slide down or M2 will slide up, whether M1 will slide down or M2 will slide down does not depend on the masses only, depends on the angle also. And it is given in the book that this M1 is equal to 1 kg and this is equal to 1 kg. Now let this angle is alpha and this angle is equal to beta. So I have already explained you how to resolve the components. Its weight is acting vertically downward. Let me put it in a different pen, is acting vertically downward. So that will be equal to M1 times G, M1 times D. Its weight is also acting vertically downward. Vertically downward is M2 times G. That is now, and I have already explained you how if this angle is alpha and this is 90 here, this is your 90 minus alpha. So to this side, if I draw a line like this, this is your 90 minus alpha, therefore this is your alpha to make this whole 90. So the component of M1G along the inclined plane to this side will be M1G times sine alpha. Similarly here, this is beta, this is 90, so this is your 90 minus beta. So this is your 90 minus beta. This is already discussed in previous problems. So if this, therefore this is beta to make this 90. So this one will be, I am not interested in this because the surfaces are smooth, but still let me write it, M2 times G of cos beta. This one will be M1 times G of cos alpha. And here the component of this acting downward along the inclined plane, this one will be M2G times sine of beta. And here is your tension, the same strings, same tension. I have already explained you in previous videos, if value of M1G sine alpha is more than value of M2G sine beta, then this M1 will slide down. If M2G sine beta, the value of this is more than value of this, then M2 will slide down. And if you look at my previous videos, I have explained the acceleration as if you can consider these two, horizontal like this, from this point, your M1G sin alpha is to this side, your M1G sin alpha is to this side, and your M2 sin alpha is to this side. So this is your M1G of sin alpha, and this is your M2G times of sin beta. This is the shortcut, and here is the tension T. This tension, this is the internal force, I don't consider. This is same thing as M1, this is same thing as M2. So the string is massless, so the net force on the system is one minus the other. Whether this is more or this is more, we have to put the value of M1, M2, put the value of G, and put the value of sin alpha and sin beta to check it. So your acceleration will be net force. Suppose this is more than this, which I have not yet calculated, right? So M1G sin alpha minus M2G of sin beta, net force over total mass is your acceleration. So since you can put it straight way to find out the acceleration. So if you put it here I am assuming this M1 is sliding down, using this as the expression. By putting the values, if I get this as negative, then M1 is not sliding down, it's moving up. Means M2 is sliding down. So let us put the values. Since M1, M2 are given as 1 kg each, so here your acceleration comes out to be, let me write it again here, M1G times sin alpha minus M2G times sin beta, net force over total mass M1 plus M2. And M1 is given as 1 kg, M2 is given as 1 kg. So this becomes 1 into G sin alpha, G. Now what is sin alpha? Sine of this angle. And since this is a right angle triangle, we are considering this as the angle, then the side opposite to this, that is, this is your perpendicular and this is your hypotenuse. So your sin alpha will be 3 over 5. Sin alpha will be 3 over 5. M2 is 1. Keep G as such. Sin beta. Sin beta will be, so this is your perpendicular, this is your hypotenuse, 4 over 5. 4 over 5. M1, M2 both are given as 1 and 1. 1 plus 1 is 2. So if you take G common, you are left with 3 by 5 minus 4 by 5 over 2. So that is equal to that is equal to G times LCM is 5. Now 3 minus 4, that is minus 1. Look, I assumed this is coming down using this expression. Now I'm getting acceleration as a negative. Therefore, this M1 is not coming down, it is moving up. Rather, M2 is coming down. Means the value of M2G sin beta is more than the value of M1G sin alpha. So here you get minus G over 5 whole over 2. So that is equal to minus G over 10 is your acceleration. So let me repeat, since I assumed this is coming down and I use this expression, I derived this expression assuming that this M1 is coming down, and while putting the values I get acceleration as negative minus G over 10. Therefore this is not coming down, this is moving up, the meaning of the negative sign. So your acceleration is equal to G over 10. G over 10 means this one is moving up with this acceleration, this one is coming down with the same acceleration. Now to find the tension, you have to apply you have to write the equations either for this or for this, right? Means since this is going up, so t must be more than this. So t times this, so t minus m1g sine alpha, let me do it here. So t minus m1g sine alpha. So t minus m1g of sine alpha is the net force on this, and it is moving up, which I explained. So that will be its mass times acceleration. Its mass is equal to m1 times acceleration. So t we have to find out. m1g goes, this term goes to the other side, m1g sine alpha plus m1 times a. m1 is given as 1 kg, this is given as 1 kg, so g sine alpha plus a, and g is g sine alpha. Sine alpha is perpendicular over hypotenuse, that is 3 over 5, that is 3 over 5, and a we just calculated as g over 10. So put the value of a here as g over 10, so you get 3g over 5 plus g over 10. So your LCM is equal to 5, 10 LCM, no need. So LCM is 10, 10 divided 5 is 2, 2 times this, that is 6g plus g. So that is equal to 6g plus g, 7g. So 7 by 10 times g is your tension in the string, right? If you wish, you can put the value of g also. So this much of Newton. So thank you. Now in the next videos I will be solving a few more numericals. This is from HCVerma, and in fact the previous Pulley problems that I solved, they are also from HCVerma, from laws of motion, from Newton's laws of motion. In fact, this one is question number 25. Okay. All right. So in the next videos, I'll be solving few more problems. Thank you.